Alright, so we are looking at example 3 and example 4. In example 3, you're asked to solve the absolute value of x minus 3 is less than or equal to 5. So this is going to be the same thing where we have two cases, but notice we have a less than or equal to symbol. So it means that when we take our second case with the negative, we're going to have to alter our inequality. So case 1 would say x minus 3 is less than or equal to 5, or case 2 would say x minus 3 is greater than or equal to negative 5. So when we're doing the negative, we flip the sign. From here you just solve for x, so we add 3 to both sides, and we get x is less than or equal to 8. For case 2, add 3 to both sides, and we end up with x is greater than or equal to negative 2. So then you put this on the number line. So our boundary points, I would recommend, last time I recommended graphing a 0, but when you have two numbers that you're graphing, I would say just make sure you get those two numbers in the correct order. So this is x is less than or equal to, so that's a closed dot. X is greater than or equal to, so that's a closed dot. And if you tested a value, so if you tested 0, you would find that 0 is less than 8, so it gets shaded on that side where it's true. If you tested 0 here, 0 is bigger than 2, so it's true here, so you'd shade in the middle. So for example 4, we have 3 times the absolute value of 2y plus 1 is greater than 28. This one's got more steps to it. So first you want to start by getting this thing alone. So you want to get the absolute value stuff alone. So that means we are going to subtract 1 from each side. You have to get it to look like this before you can do your cases. So we'd end up with 3 times the absolute value of 2y plus 1 is greater than 27. And I know it seems like you want to use the distributive property, but when we have absolute value brackets, you can't do that because you change the value of what you're trying to solve. So you undo what's happening to the absolute value brackets. That means you divide by 3. So we'd have 2y plus 1 in absolute value brackets is greater than 9. Now we have what we had up here in example 3, where we can break it down to our cases. So case 1 would say 2y plus 1 is greater than 9. And then case 2 would say that we have what's on the inside, 2y plus 1, but because we're looking at the negative, we have to flip our inequality. So 2y plus 1 is less than negative 9. So from here now you can solve for y. Subtract 1 from each side, and we get 2y is greater than 8. Divide by 2, which would mean y is greater than 4. If you look at case 2, you subtract 1 from both sides. So on the left we have 2y, on the right we have negative 10. Divide each side by 2, and we get y is less than negative 5. So if you put it on a number line, again, just make sure use these two numbers, your boundary points. Make sure you have them in the correct order. So negative 5 and then 4. So this one that relates to negative 5 says less than. That's an open dot, and it's any value smaller than negative 5. So if you tested 0, it would not be true. If it's not true, it means you shade on the opposite side. Y is greater than 4, so we have an open dot at 4. and it's any number bigger than 4. So again, if you tested 0, it would not be true, so you'd shade on the opposite side. So you end up with this situation where they're shaded in opposite directions.